In the previous video, we discussed about how we apply this substitution to solve the problems, correct? Now, in this video, we are going to understand and we are going to do few concepts of trigonometric substitution. Okay. Now, what we mean by trigonometric substitution in the sense, if you remember, last year in the chapter trigonometry, you had different trigonometric identities. Like you had multiple angles, you had submultiple angles, you had so many of these formulas, correct? Now we are going to make use of those formulas and how to go about it. That's what we are going to understand. All right. Now let me show you simple examples. But before that, let's recap the trigonometric formulas what you had. Fair enough. Now we generally start with multiple and submultiple angles. Then we'll go into the other cases. Now once we do multiple angles, let's start with sine. So we have sine 2 theta. This is 2 sine theta cos theta, right? Or 2 tan theta divided by 1 minus tan square theta. Sorry, 1 plus tan square theta. 1 minus would be tan 2. 1 plus tan square theta, right? This is 1. Or cos 2 theta. The next one, this is cos square theta minus sine square theta. This is 1. Or the other one, 2 cos square theta minus 1 or 1 minus 2 sine square theta. Or the last one, you can say 1 minus tan square theta divided by 1 plus tan square theta. So you have 4 different formulas for cos 2 theta. Then you have tan 2 theta. 2 tan theta divided by 1 minus tan square theta, correct? 2 tan theta by 1 minus tan square theta. Now these are the identities for 2 theta, that is the angle. What if we have 3 theta? So that means what if you have something like sine 3 theta? This is 3 sine theta minus 4 sine cube theta, right? Then if you have cos 3 theta, 4 cos cube theta minus 3 cos theta, right? Next, if you have tan 3 theta, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Okay, now these are the multiple angles what you have, correct? Now submultiple angles, same thing. Instead of theta, you are going to write theta by 2. Or if it's a theta by 3 submultiple angle, you'll write it as theta by 3. Right? Now, why I'm telling you all these things is, suppose if I ask you integrate sine square x, integrate cos square x. Okay, you can't directly integrate it. Now, in those kind of problems, we are going to make use of these trigonometric identities, alright, or trigonometric formulas, you can call it. Yeah, let me show you one simple example, then we look into the problems part later on. Yeah, so let's do one simple problem now. Let's try and integrate sine square x. Yeah, it's very simple. See, integral of sine square x dx. Now, directly you cannot do it. So what we do is we make use of cos 2 theta. Then we can do substitution method. That's why. Yeah. See, sine square x, let's take it in terms of cos 2x. Now, what do you have? So you know that cos 2x is equal to 1 minus 2 sine square x. Correct? Or 2 sine square x is 1 minus cos 2x. Sine square x becomes 1 minus cos 2x whole over 2. Correct? Now this you substitute in the integral form. Now if you do that, you will get the value as integral of 1 minus cos 2x divided by 2 dx. Now the 2 which is there in the denominator, that's a constant, so keep it outside. That means you'll get this as half integral of 1 minus cos 2x, sorry, dx, right? Or you can write this as half into integral of 1 dx minus integral of cos 2x dx, correct? So this is what we have. Integral of dx is x, you know that. I mean, that's very simple. But for the cos 2x part, remember what we used to do in the previous cases of substitution? You can take 2x as t and then you can substitute, right? So we are going to do the same logic here also. Fine. That means what you're going to get is, this is going to become half times. So you're going to have the whole thing x minus, so you have cos 2x, right? Now I'll do one thing. I'll write the cos 2x as it is for now. Now we'll do the cos 2x part. That is, we are going to integrate cos 2x. For that, what do we do? Say 2x is equal to t. So 2 dx by dt is equal to 1. So 2 dx is equal to dt. So you know dx will be dt by 2, correct? I mean, I don't have to write that separately. So what do you get now when you're integrating? Integral of cos 2x dx. This is going to become integral of cos t into dt divided by 2, right? So you'll get this as half integral of cos t dt. Now once you integrate this one, once you get the value of this one, we need to put it in this cos 2x dx form, isn't it? So you are going to get half integral of cos t dt, which is basically half into sine t, correct? Plus c and all, guys, will do it at the end, no worries. Half into sine t. Now what is t? 2x. So this is going to become half sine 2x, right? So what did we get? We got the value of sine integration of cos 2x, correct? Now what do? We are going to take this and we are going to substitute it, isn't it? So substitute where? You're going to take this, substitute in terms of cos 2x. Now once you put it there, so what you'll get is that half into x minus half sine 2x, correct? So both are integrated. Now write plus c, or this is going to become x by 2 minus 1 by 4 into sine 2x plus c. So this is going to be the final answer. X by 2 minus 1/4 of sine 2x plus c. Fair enough? Now this is how you do sine square x. Now don't you think if I give you find cos square x, you can use the same cos 2x itself, but the final answer will change. See, this is what we mean by using the trigonometric identities and substituting, finding the answer. Understood? Now, see, I just showed you an example wherein we are going to use just one of them. Now, there are so many trigonometric formulas like this, correct? Sine 2x, sine 3x, so many are there. So, we'll see in the next video, that is, we are going to solve problems. We'll see how many of these formulas we'll use and in what way we can use and solve the problems. All right, so we'll solve problems from the next video onwards.